Hi students, in this video I am going to discuss about communication interface. In embedded system, this communication interface is essential to communicate with various I/O subsystems and outside world. There are two types of communication interface, onboard communication interface and external communication interface. This onboard communication interface is also called as device or board level communication interface, and this external communication interface is also called as product level communication interface. First we are going to see onboard communication interface. The first device is inter-integrated circuit I2C bus. It's also called as I2C bus. It's a synchronous bidirectional half duplex two-wire serial interface bus. The I2C bus comprises of two bus lines, SCL line and SDA line. SCL line is serial clock line, SDA line is serial data line. This serial clock line is responsible for synchronization of clock pulses, generating synchronization of clock pulses, and serial data is responsible for the transmission. And this I2C bus is a shared bus system. So many number of I2C devices can be connected with the I2C bus. And which are the devices are connected with the I2C bus can be act either as a master or slave. And these devices can be a transmitter or a receiver. Okay, and here the master is responsible for initiating the data communication and controlling the data communication, but the slave will be waiting for the command from the master, and it respond after getting the command from the master. And another thing, though the slave is acting as transmitter, it cannot produce a clock synchronization pulse. Only a master is allowed to generate the synchronization of clock pulse. Next one is serial peripheral interface bus, SPA bus. This is synchronous bidirectional full duplex 4-wire serial interface bus. And this SPA was introduced by Motorola. SPA is a single master multi-slave system. Okay, it can have multiple bus master, but at a single point of time, any one master will be having the control. And here we have four lines: MOSI, SCL, MISI. MOSI is master in slave out. So MISO master in slave out. MOSI master out slave in. And SCL we have seen in the last one, it's a serial clock line. Then another one is SS. This is slave select. Actually, this slave select signal is a active low signal. Okay. So we must give 0 to enable the signal line. And this MOSI master out slave in, this bus line is used to carry the signal from master to the slave. And MISO, this signal line is used to carry the data from slave to master. And SS, it is used to select any one of the slave from the list of slaves. The third one is Universal Synchronous Receiver Transmitter. It is UART. This UART is based on UART is asynchronous form of serial data transmission. Okay, and this UART does not require a clock signal for the synchronization of transmission end and receiving end for the communication. But instead of that, it relies upon the predefined agreement between transmitting device and receiving a device. So here the start or end of the communication can be indicated by inserting extra bits along with the bit stream. So while sending the byte of data, start bit will be adding at the beginning of the data byte, and end bit will be inserted at the end of the data byte. and this start byte will be available in the LSB side, least significant side, and this start bit will be available in the MSB side. Most significant bit of the data stream is a stop bit, and least significant bit of the data stream is the start bit. And this start bit will indicate or will inform the receiver that it is the data byte is about to receive. Okay. Next one is parallel interface. This parallel interface is used in the embedded communication for communicating with peripheral devices which are memory mapped with the host processor or host controller. Here the communication through the parallel bus is controlled by control signal interface, and this interface are having read write control signal and device select signal. See, all the devices which are connected with the host, all the devices will be having this device select signal, but that device will be activated when this signal is asserted by the host processor or host controller. And here the direction of communication means it's data from host to device or device to host. It can be controlled by read and write signal. If it is read, it's device to host communication. If it is write, it is host to device communication. Okay, next we are going to see some of the external communication interfaces. The first one is RS-232C, recommended standard number 232, and revision is C. It's a full duplex wired asynchronous serial communication interface, and this RS-232C supports two types of connectors, a 9-pin connector and a 25-pin connector. The next one is Universal Serial Bus, USB. It's a wired high-speed serial bus for data communication. And this USB communication system follows the star topology where the USB hub will be at the center and USB peripherals are connected with the USB hub. Then the third one, the next one is IEEE 1394 fireware. It's a wired isochronous high-speed serial communication bus, and it is also known as high-performance serial bus. It supports 400 to 3200 Mbps data rate. Here we have three types of connectors: 4-pin connectors, 6-pin connectors, and 9-pin connectors. And out of these three, the 4-pin and 6-pin connectors are carrying power also to support the external device, and it can supply unregulated power in the range of 24 to 30 volt. Thank you.